Bismillahirrahmanirrahim. Okay, Assalamualaikum and a very good afternoon. So today we're going to continue with the second part of signal operation. Okay, this is just to recap what we have learned earlier in the previous lecture. So we have discussed on time-based and amplitude-based operation. So just look at the fundamental equation for each type of operation. So for time-based, time reversal, so you'll notice negative sign inside the bracket. Amplitude-based, negative sign outside the bracket. For time scaling, there's additional parameter inside the bracket. Time shifting, there's positive or negative parameter added inside the bracket. And for amplitude scaling, you can notice additional variables outside the bracket, and amplitude shifting, whether the signal being shifted up or shifted down outside the bracket. Okay, so now what happened if you have more than one operation in one equation? Okay, so for example, we usually see for amplitude scaling or shifting, only one part is changed. But in this case, you have both amplitude scaling and also shifting. So for example, if you have this equation and given the original signal as this, so what you need to do, the first one, you need to settle the first part. Okay, so in this case, you know that the amplitude being scaled by -2. So this is the original amplitude. So all amplitude will be multiplied by -2. So how the signal looks like? So now the same signal at the same t, because there's no changes on t. Okay, so this is still -2, and here is 1, and here is 3. And the amplitude here being multiplied by -2, so it becomes multiplied with -2, so it becomes -6. And here -1 multiplied with -2, you got +2. So then what you need to do, you need to reorder the axis, because you cannot have negative signal on top. Okay, so now redraw or rearrange the axis. You will get +2, and then -6. Okay, so this is -6, and here is +2, and the t is -2. Here is 1 and 3. Okay, what will happen next? Okay, so you have done the first part. So second, you need to settle you still have the shifting. So all signal will be shifted up by +1. Okay, positive means the signal being shifted up. So what you have is this. Okay, so the amplitude 2 being shifted up, +1 become 3, and -1 shifted up by 1, you get -5. Right, so the signal now already in a new shape to fulfill the given equation. Okay, so what will happen in time-based operation if you have more than one operation? So first, look at the given equation. You may notice that there's additional variables inside the bracket. So that's time scaling and also time shifting. Okay, remember basic equation for time shifting, you should consider negative in the middle. Okay, so there are three methods to solve when you have more than one operations. Method 1, okay, so the step is as shown here. Method 2, okay, you can follow the steps. So I would like to discuss further on method 3 because this is the most easiest, okay, the easiest and structured way of solving a problem when you have more than one operations in an equation. Okay, so you need to follow this procedure. Okay, so first, when you are given a signal, for example this signal, so you need to plot the original signal but replace t with tau. So at the moment you have the axis as t, so you need to redraw the signal, but the x-axis, instead of t, it becomes tau. Okay, but the values of t of tau is still the same, are still the same as t. So you still have 3, 1, 0, and also minus 2, and the amplitude is also remain the same. Okay, next you need to calculate the new t values based on tau. So what is tau? Tau is whatever equation inside the bracket. So tau equal to, in this case, negative 2t minus 1. So you need to solve for t. So what is the new t? Next, you need to plot the new t-axis or new t values below the tau signal. And lastly, plot your new signal. Okay, when you have the given equation, so you can determine what is tau from whatever equation inside the bracket. So in this case, tau equal to negative 2t minus 1. So then from here, you need to determine what is t. So in this case, t equal to tau plus 1 divided by minus 2. Okay, so let's follow the given step. So first you need to plot the given signal on a new t-axis. So the given signal originally in t-axis. So you need to replace t with tau. As simple as that. Okay, so all values remain the same, okay, in t and the amplitude. So next, you need to calculate the new values of t from tau. Okay, we know that tau equal to whatever equation inside the bracket. So you can get the equation of new t. So then you need to calculate the new t values based on tau. So what is tau? Tau you can get from this graph. So the new t, what happens when tau equal to 3? So your new t equal to negative 2. Okay, when tau equal to 1, so your new t equal to negative 1. When tau equal to 0, so your new t is still 0. And when your tau equal to negative 2, so your t equal to 0.5. Okay, so now you already have your new t values. Okay, so originally you have t, the signal in t, you change it into tau. So this is the signal in tau. So then you need to plot the same shape of the original signal but in new t-axis. Okay, so this is your new t-axis from your calculation here. When tau equal to 3, your new t equal to -2. When tau equal to 1, new t is -1. When tau equal to 0, you get it. Okay, so here is 0.5 minus 0.5. Okay, please check this calculation. Okay, negative 0.5. When you have the tau equal to -2, it is 0.5. So next you need to redraw the signal on new t-axis. So how the signal looks like? So just copy the same shape, okay, the same shape at the same position but on the new t-axis. Say the amplitude remain the same because this is time-based operation. Okay, so now the signal become xt. Okay, finally look at the axis. You have negative values on the right hand side and positive values on the left hand side, so you need to rearrange the axis position. So finally you get the final signal. Okay, let's have another example. Okay, given a signal as shown, so you need to sketch a new signal given by this equation. So from the equation you can determine what is the tau. Okay, so in this case the tau equal to 4t plus 2. So what is your t new? Equal to tau minus 2 divided by 4. Okay, so as mentioned in the first step, you need to replace the x-axis from t to tau. So this one t is no longer valid, so you need to replace with tau. So this is the first step. So this is supposedly the second step. So the third step, you need to calculate with what is your t new from tau. Okay, so when tau equal to 4, so your t equal to 0.5, tau equal to 2, so your t equal to 0, tau equal to 0, t equal to negative 0.5, tau equal to minus 2, t equal to minus 1, and tau equal to minus 4, t equal to minus 1.5. Okay, next step, you need to put all the t new values onto the axis. So this is the fourth one, the fourth step. So just draw the x-axis. It is now t new. So when tau equal to 4, it is 0.5, and 2, 0, 0 is negative 0.5, and negative 2, negative 1, negative 4, negative 1.5. Okay, the same position. Okay, same position as the original axis. Okay, now you need to just redraw, copy the same shape of the signal, the original signal, onto the new t-axis. So here, okay, a bit higher. There you are. So then draw the y to 0. So this is your y-axis. yt. So this is your new signal, yt. Okay, next I'll share how to add or subtract two signals, okay, at least two signals. So you need to consider point by point. Look at how many components the signals have. So in this case, the first one you have a signal of ut. So the amplitude is 1 across t, positive t, and the second one you have a cubic which having the amplitude of 1 from t0 to 2. So you have two portion here, or two section. So you need to consider, because you have the different amplitude in the second signal, so you need to consider the first portion and the rest of the t. So in this case, you'll be having from 0 to 2 and 2 onwards, okay? So what happened from 0 to 2? So 0 to 2, you have the amplitude 1 plus 1 here, plus 1, become 2. Okay, and from 2 onwards, you have amplitude of 1 plus 0, it is equal to 1. Okay, so this is 1. So from 2 onwards, the amplitude is 1. So this is your signal. Let's look at another example. So again, you have two portions, okay, up to 2. So this is equivalent to, again, 0 to 2. Okay, let's consider the amplitude from 0 to 2. You have amplitude of 1, but here is net minus, okay? 1 minus 0, you get 1. And from 2 onwards, 1 minus 1, you got 0. So this is your final output. Okay, same goes to multiplication. So you need to consider point by point multiplication. So for example, here up to 3. So here equal to, so 0 to 3. Okay, from 0 to 3, 1 multiply with 0, you get 0. Okay, from 3 onwards, 1 multiply with 1, you got 1. Okay, so this is the answer. Look at the second example on multiplication. So you have increasing t, yt equal to t across t, and yt equal to 1 across t. So what happened here? For example, you have at 1, the value is 1. So 1 multiply with 1 is 1. Okay, and then at 2, the amplitude is 2. Multiply with 1, you got 2. So the t keep on increasing, multiply with 1, so the value will keep on increasing. So this is your output, yt. Okay, when you plot a signal, please make sure you label it properly, yt, and the x-axis t. So that's all for now. So in the next lecture, I'll show you how to sketch a signal from a given equation and how to write an equation from a given signal. Thank you.